Hello, Michael. While playing this model, I realized that during our previous discussion about the probability, saying that if the ants arriving at two pile of food, this two pile of food, they are having same distance to the nest. This is nest. They are the same amount. So our hypothesis is if the ants arriving at the two pile of food at the same time, then the colony were trying to get the two pile of food at the same time, and both of them should almost finish at the same time. That is our assumption. However, this is not the case. Let's have a look. This first, this second. Okay, so this is finished. But look, this first, this second. They are almost finished at the same time. They are getting two pile of food at the same time. So let's look again. This come first. However, this one will finish first. It's still counter our hypothesis. This one arrived first. And this one finished first. This one first. But this one will finish first. Oh no. But at least they seem as getting two pile of food at the same time. But do trying to pay attention to the middle parts. I mean, trying to pay attention to the very thick parts of the ants, like this one. Okay, pay attention to these parts. Let's look at this again. Okay, these two almost get at the same time. But look, pay attention to this part. Okay, these two finish at the same time. Look at this. This one first. This one finished first. But the reason why I ask you to focus on this is because I do not think the major cause for explaining which pile of food will get finished first is not depends on which ant gets to the pile first or which pile gets the first ant. Rather, the real cause is which pile of food is closer to this chunk of ants. Both of them finish at the same time. And I think that's because the chunk, the most thickness of the chunk of the ants is closer to that pile of food. Okay, look, this part is a lot more bigger. So it finished first. Now watch it again. Now this ants coming down from this part to this part. This one first, but observe this one. See, all the ants moving towards here. Now see, okay, almost the same amount. Now it's flowing towards this part. So that's interesting, right? Okay, it looks like they are equal speed. They both share the equal amount of ants, so they finish almost at the same time. This one first, but watch. Now it seems this part is going to finish first because it has more ants flowing towards this area. Now it's being tracked from here. Do you see what I mean? I think the course is not which pile gets the first ant. The real course for the pile of food to get finished first depends on the chance of having the largest thickness of the block of ants being attracted to the pheromone, where the pheromone is closer to that pile of food. See, at this moment, the pheromone, the pheromone among this area and among this area is gone. The only pheromone which is available is in this part. So the surrounding ants all flow towards here. So suddenly, this area has a lot of ants. And when they consume all the pheromone is gone, they will be sent out from this area. So this pile of food has the most exposition, has the larger chance to receive a lot more ants than this pile and this pile. So I would predict that this pile of food will be finished first. Let's continue. Well, yeah, it finished first, but there is a chance that this one will be finished very fast as well. However, right now, look at this. All the ants has been absorbed into this area. So that's why the new hypothesis is different from our previous one. So look, this pheromone is gone. All the ants has been sucked into this area.